Hello all. Today we are solving LeetCode problem number 1022, sum of root to leaf binary numbers. So you are given the root of the binary tree where each node has values either 0 or 1. Each root to leaf path represents a binary number starting with the most significant bit. So what exactly this means, they have given the example here. So this is the given root. So when we traverse down this route, we will have this and this as a path, which is nothing but 101 as a path, and based on the second path, which is a 1 0 and 0 to 1, will result in 101. I'm so sorry, the first path will be resulting in 100. So and next you have 110 and 111. So when you represent this binary number in base 10 format, you get 4, and this one will be 5 and 6 and 7. And when you sum this up, 4 plus oops 4 plus 5 is 9 plus this is 13, so you get 22. So this is the output which you return. So how do we solve this problem? We know this is a given as a binary tree, so we need to traverse in a binary tree using DFS. You traverse each and every node, and you cover the path, and you will be getting the number which or the value, node value, whichever is present in the node. So using that, you can create the numbers and then convert it. For example, there are many ways to store the values and convert them. So first thing is you can use string format. So you can collect the value, every value, convert into, store it as a string, and then when you reach the leaf node, you can convert back into integer format and add it to the result. Or you since we are using this binary numbers, we can use bitwise operations. So which is nothing but you will have 0 as the initial number, then you will do left shift, and you will have two numbers, and now you will add the value at the node, which is nothing but, for example, if you're considering root, you have 1, and you will do or operation, or bitwise or, not add, bitwise or operations, so which will be resulting in 0 1, which is the output which you will be getting for this particular node. And when you move down the nodes, when you expand the tree, again you have to do the left shift, so you will have 0 1 0 added with 0 as the next node, which will result in 1 0. And further moving down the node, you have 1, so 0 1 0 0, left shift, and again bitwise add, you get oops, sorry for this, 1 0 1, so which is nothing but the output which you are getting. And when you reach the leaf node, you add to the result. So node dot value will be added with the result, equal to result. So this is not the correct expression. It should be result added with node dot value if it is a leaf node. So this is how we will be adding these values, and finally by using the DFS function, we will cover every path, and you will have a global result value which will hold all the sums. And finally, when you are done with the DFS call, recursive call, you return result, right, which you will carry all the sum. So with this idea, let us go ahead and code this up. So this will take time complexity bigger of n times because we are covering each and every nodes. So this will be the time complexity, and let us code this up. So first we want to define the result, assign as 0 since we want to have this as a global. So self dot result will be is equal to 0, and define DFS where you will pass in the node and the value which should be carried, the binary value. So bin will be a function, so let it be a b. So now you start with the left shift, so b left shift by 1, and now you add it. So bitwise or, so b equal to no dot value. So now you have the operation done, and the b has the b holds the value which is after these two operations, which means you have the number ready at the particular level. And now you have to check if it is a leaf. If it is a leaf, you add the b, else you navigate to the next, which is left and right. So since you have to check the leaf, if not node dot left and not node dot right, then it is a leaf. So now what you do is you self dot result will be added with b, and then you return. So if not, if no dot left, if it is there, you expand left side, so DFS no dot left, along with the b you pass in the b value whichever is done after this calculation at the respective node. So if no dot right, DFS no dot right, pass in the b value. So that is for this function. So now you call it, so DFS root dot, root and 0, your initial value will be 0, which is what we are passing in, and return self dot result. So that is it. Let us run it. Sorry for the issue. Let us run it and submit it. And there you go. Thank you.